Okay, so now that the ink is dry, we're going to go ahead and attach the LEDs. LEDs have a long prong and a short prong, and these are the cathode and anode ends. And if you look inside of the lens cap, you'll actually notice that the LED itself has a chiseled side and kind of a concave side. And an LED is essentially a gate. It's polar, and it only allows electricity or current to flow from the long terminal to the short terminal. And these are the cathode and anode ends. So the short terminal is always going to be connected closest to ground, and the long terminal is going to be connected closest to the source of the current. In this case, it's going to be our GPIO pins on our microcontroller. So what I've done with this LED is I've stretched out the legs so that they can bridge across the contacts, and I have to make sure that I do put them on the correct way. Now, right now I have these LEDs appearing on the surface, the inside surface of the lantern. If you wanted them to be on the outside surface, we'll reverse the print so that you could see the exposed circuitry on the outside, which might be kind of cool. You can actually take these prongs, and they're flexible enough to get it in between the paper and bridge it like this, and then you can have the LEDs on a different side if you wanted to. So that might be interesting, and you can try that for yourself. But to get these things to stay on the contacts or the pads that I've made, I need to actually use a little bit of copper tape. So you want to get them to rest as flat as possible before taping them on with copper tape. Copper tape is a cheap, flexible copper material with an adhesive backing. It's a little bit tricky to work with just because it is somewhat fragile, but you can get a lot of it for not a heck of a lot of money. And the adhesive itself does have a little bit, I think it's the adhesive that has some conductivity, or maybe it's just the exposure to the copper through the adhesive that has conductivity. But it's not a perfect conductor, so that means it has a little bit of resistance in the copper. So you'll notice that in the circuit I don't have any resistors, and usually when you hook up an LED to current, you need to have a resistor that prevents the LED from being overloaded and blowing out. But because the copper itself is not a perfect conductor and has some of that resistance, I can skip the extra resistors in the circuitry here and get away with just having the LED with no resistor. So that's how I can attach an LED right there. I can do the same thing over on the other side as well. Now, when I fold the lantern, you'll notice that this time when I fold the lantern, it's actually going to fold the copper, fold the electronic ink right there. And that might actually break the connection across the corner. So sometimes what I like to do to make sure that there's a good solid connection across the corner of paper or across a fold, if it's not going to be a flat circuit, is I actually use a little bit of copper tape to bridge that connection and just make sure that the connection never gets broken across the ends of the terminal, like this. And that helps. So you might ask, how do I know whether or not I've got a good solid connection? And I can use a device called a multimeter to measure the resistance. So when you turn on a multimeter and you switch it to resistance, and it's measured in ohms, which is this omega sign right there, you might see that at the beginning it says 0L, and that means that there's no connection between the two terminals. Now if I bridge them together like this, you'll notice that it'll drop down to 0 ohms. So I can test any connection and measure its resistance simply by touching both ends of the contact, and that's helpful for finding any breaks in the connection, like this. Now, the LED, you're not going to be able to test both sides of the LED and get any sort of, well, you might get a little bit of conductivity. Notice it says 15 mega ohms of resistance. That is a lot of resistance right now. So typically you need higher voltage to be able to drive and measure the resistance. So next, after we finish putting on the other LED, we can test the circuit and then finish assembling the